Hello guys, how are you?
Good. How are you?
Fine, thank you. So tonight, um, we'll complete. Well, we'll do. We will revisit the topic that I introduced some time in the past. It's called the quality uh management. This time around, we focused on statistical quality control. Before I do that, I want to show you a few things. Okay, I'm gonna share, bring this down. Share this, okay. Now, give me one minute. Let me open your classroom. Here, I want to show you the announcement. First of all, this week, what is due and what is not. Okay. Now, we are, again, like I say, we'll be revisiting the quality control, quality management, specifically on the focus on statistical process control as it relates to quality. Now, the assignment for the week, classwork 9, which I will provide as soon as we finish. Then you can now go and practice on them. So we are going to be finishing on time so that you have enough time to work on those and upload. It will be on Excel. I will also extend the due date to tomorrow so that if you don't finish it today, you can finish it tomorrow and upload. Okay?
Thank you. Thank you.
Oh, sure, of course.
Thank you. Thank you, sir.
You're welcome. So now, of course, you also know that you can have access to this by going to your models and then scrolling down to the week we are now in model 10, which is the statistical process control. And this process control have a lot to do with quality because if you control the process, that means they go according to the plan or according to the specification. That means most of these specifications are usually made to make sure that what you are producing or the claims you are making about your product is true. I mean that the product reflects those claims. Okay. Now from there you can download this presentation that we're about to do now. This one here. This is the presentation. This is the spreadsheet. Okay. Now, but for the classwork, you make your own spreadsheet. If you like, when you make your own, you can copy the part of mine, to put your data. But I recommend that you make your own. You can watch. I'll save this video and put it as when I put the classwork. I'm gonna put a link to this video under it so that you can watch it and do it by yourself. Okay. Now let's begin. It says here, statistical process control. Can you see the screen, the presentation on the screen? Can everybody see it?
Yeah, the PowerPoint?
Yeah.
Yeah.
Oh, good. Excellent. Now, statistical process control, statistics is used in many places, especially even in the industry, in the quality control process. So anyway, the statistical process control have a lot to do with using the statistical method to make sure that the processes meet standards. I mean, if they meet the standard, they are considered to be a quality process. I mean, the outcome of those process, like the product or service being rendered, if they meet the standard, that means they have quality. So all processes have we have two main degrees of variability. Even if it is a uniform process, there's going to be some variability. For example, two siblings, yeah, they're from the same parents, but still they're gonna be, one of them might be taller, a little bit taller than the other one. So there's gonna be some variability, no doubt. So there's what we call natural variation, which are the many sources of variation that occur within a process, even one that is in statistical control. So even a process that is in statistical control can have natural variations. So in other words, natural variations form a pattern that can be described as a distribution. So which means that as long as the distribution or the measurement, output measurement with respect to that process remains within specified limits, then we say that the process is in control. And natural variation can be, you can tolerate natural variations. Now, the one that you are concerned is the assignable or spatial variation, whereby it can be traced to spatial reasons. I'm gonna give you an example. If the quantity of let's say a bakery, let's say that the weight of the bread, each bread is, let's say, it's 12 ounces. Some might be 12.3 ounces, some might be 12.1 ounces, some might be 11.99 ounces weight. Those are natural variation. But when one is 12 ounces, the other one is 15 ounces, the other one is 10, that's when we get concerned. That one is noticeable. That is kind of what we call assignable or spatial variation. So assignable or spatial variation can be traced to a specific reason. Things like machine wear and tear, misadjusted equipment, okay, then fatigued or untrained workers, or even new batches of raw material that these are among the things that can cause assignable variations. Now, whose name is IFE? IFE. Whose name in the class is IFE? IFE. I want to see so I can check the attendance for the person. Anyway.
Don't forget about me.
I've already checked yours. Now.
Thank you, sir.
Welcome.
Did you get me? Did you get Blanche Gold?
So, process variability versus the role of operation managers. Let us examine that. Now, like I explained a few minutes ago, the one we are concerned is the assignable variation, not the natural variation. So, both natural and assignable variations distinguish two tasks for the operation managers. One is that the operation manager must make sure that the process is capable of operating under control with only natural variations. The second one is that the operation manager must identify and eliminate the assignable variations so that the process will operate within or will stay within or under control. A few things we need to know about this process control thing. Okay. Now the first one, okay, Justin. It's Justin. Yes. So the first one, give me 1 minute. I'm taking their names. Pico. Okay. All right. The first one is that while studying the process data in the 1920s, Walter Schwartz of Bell Laboratories developed the control charts that we use for measuring both the natural and the assignable variations. Now, based on what he found out, or in general, what we use the control chart to do, we say that a process is operating in a statistical control when the only source of variation is the natural variation, that's not common cause. But the process must be, first be brought into statistical control by detecting as well as eliminating the assignable causes of variation. Another thing we need to know is that when the process is in control, it is predictable. When it's in control, it is predictable. Now, for the operation manager, then the objective of a process control system is to provide a statistical signal when assignable causes of variation are present. So when they see that signal, they can quickly take the right action to eliminate that assignable causes. Whose name is Pigot? What's the last first name? Somebody whose name is Pigot, Pagou. What's their first name? Okay. I'm looking for this. I want to make sure I have everybody's name.
Did you get me on the attendance?
It's Pigot, Pagou.
Nah, Ife, IFE.
Pagou. That's you?
Nah, I'm asking, did you get me on the attendance too?
Ife. What's your first
Yeah,
name?
Ife, IFE.
Yeah, what's your first name? IFE does not show it doesn't show on my what's your full name?
Ife Oluwami for IFEOLUWA. Odusanya, ODU.
Odusanya, okay.
Yeah.
I have you now. I'm looking for only one person now, the Pagu. All right. Now let us see. Before we can check if a process is in control or is in statistical control, or if the process is working very well, normally we try to figure out the natural variation and the assignable variation. Now, to do that, we need to take some samples and then check the samples. Make sure that they fall within some given ranges. If they fall outside those ranges, then something is wrong somewhere. So in other words, since natural and assignable variations, because natural and assignable variation are possible, most statistical process control uses averages of small samples. If the sample can be taken at randomly, make sure that there's no biasness. So we do it randomly. We use averages of samples as opposed to data on individual parts, because the amount being produced at each particular period of time period might be a lot. So individually, it might be a nightmare to check them individually. So we use averages to do that. So we'll do some examples tonight, and then we go from there. Let me just bring these two people in. I have this one, Diana. Okay. All right, bring them in. So now, having said that, we can now proceed to a few things that we use to identify these two types of variations. Tonight, we'll be focusing mainly on the control charts. The purpose of control chart is to help us distinguish between the natural variations and then the variations that are due to assignable causes. We'll build the control charts, and then we'll look at observe the control chart to see the variations, the one that fall within the given range that we choose. We will be the one that is having the type of variation we call assigned variation. Now, so in the process of building the control chart, we have three distributions that are a result of three processes. Well, I want to show you a chart, right? That will show you, you see the one that is is a process that is in control, and the one that is out of control. Look at the chart here. As you can see from here, this one is in control. When the special forces are eliminated, this one is not in control. You can see the difference. You can see the center line from here all the way to the end. I can see this from this two chart deviating from this center line because
Hey,
of
Professor,
yes.
I'm following you, but I'm just saying, I just wanted to know, are you putting this on YouTube too
Yes,
as
sir.
well? Okay, yes, we're good.
Yes, I'm gonna put it on the link in
Yes, sir.
in the classwork that you do, so you can watch it again.
Yes.
The classwork, yeah. So you can see that this one is out of control due to the presence of the assigned variation. So now when it is removed, it becomes in control. This one is in control, and it's not only in control, it is also capable. But this one is in control, sure, but it's not capable. It is too the variation is too much. It's like excessive. We want them to be in this form or this form. Okay. Now, the control chart for variables. Now, when monitoring variables, we make two charts. Actually, there are other type of chart, but tonight we'll be focusing on two charts. Then we'll discuss one of them elaborately. Next week, we'll round up with the other remaining two. Okay. First one is the X bar chart. The X bar chart. Now, the X bar chart tells us whether changes have occurred in the central tendency. In your statistics class, you know the measures of central tendency: mean, median, and mid-range, mode as well. So now the X bar chart tells us if there's any change in this central tendency, and the change in this change, if there is any change, it can be due to the factors that it can be natural variation or even or assigned variation. Now, it can be due to different factors. I already mentioned some of them in a previous slide. Things like wear and tear on the tools that were used to produce the product, or a gradual increase in temperature that affected the quality or size, whatever. Or there's a different method is used to make the product, or that the people working on the product are just tired for that time and they are making a lot of mistakes. Can be any of these things. So S-chart will tell us that if the process is in control, it will tell us that it's in control. If it's not, it will. R-chart is the indicate the gain that a gain or loss in the dispersion has occurred. Now, this kind of change might be due to warm bearings, loose to erratic flow of lubricant to a machine, or to even sloppiness on the part of the machine operator. So we'll focus more on the S-bar chart tonight. Okay. So now, to setting the mean chart limit for the S-bar chart. Now, generally speaking, if we note, from past experience or from past data, that if you know the population standard deviation of the process, now, if you know that, then we can use these two formulas to find the upper control limit, lower control limit. Upper control limit is limit up, where anything that go beyond that is out of control. Lower is down. Anything that goes below that is out of control. So if we know the value of the population standard deviation, we can use this through two formulas to find the upper control limit and then lower control limit. The first one is for the upper control limit is x bar plus z delta x bar. So it means mean plus the standard score z times standard deviation of the sample mean.
So I'm sorry. So Z is different from Z score?
It is some is z score, of course, it's z score.
Okay, I'm sorry.
It tells us the number of standard deviations away from the
Gotcha.
mean. Number of standard deviation away from the mean. That's Patrick. Okay. Now, for the lower control limit, we use this. X bar again, sample mean standard score, which is z score. We tell us the number of normal standard deviation away from the mean. Then, of course, standard deviation of the sample mean. Now, but most time we don't know the population standard deviation, so we use this formula here. That is this type. See this type here. S bar plus A2, then R bar, where R bar is the average range. A2 is the value that I found from table 1. X bar mean the mean of the sample mean. Now, because of the like I said, because we most time we don't know the population standard deviation, so we can do our calculation using this formula here. Now, this part A2, we can find it from this table here. You can see this sample size and mean factor for that is assigned to each sample sizes. That's A2. For example, 2 is assigned 1.880. 3 is assigned 1.023 for the A2. So, and so on and so forth. Now, before we do any computation on that, I would like to say, okay, let's see what is that control chart. Anyway, I'll try it in this question 1. What are the control charts? It says, before we start using these formulas, applying them, let me give you a general picture of what a control chart, how the control charts might look like. Look at it, says here, create an S-bar chart, S-bar control chart, and explain what the control chart shows pertaining to the process being in statistical control. Now, I can just use this data that I generated to do that. I'm going to take you to Excel for question 1. So this one, we're not going to be using this for that. So I'm going to move this things down. I just wanted to show you what a picture of what a control S-bar chart look like. So I'm going to bring it down here. So let's say that we have a process. Let's say that this is the weight of in ounces, the weight of cereal. Let's assume that this is weight of cereal, and we want each being manufactured. The average weight of cereal, X bar, that's the average weight of sample of cereal being manufactured by a cereal company. Now you want to see if these weights are in statistical control, if this output is in statistical control by using a S-bar chart. So now, assume that the mean weight is 14. These are just given. In the next example, we will see how we can get them. So assume that the mean is 16 since 14, and the upper control limit is 16, and lower control limit is 6. Is this process in control? Like we'll see. First of all, first is to make sure that this the mean UCL and LCL are continued to the end. So we're gonna copy all of them down here. Now we can place our control chart on it. So I can just put this, all of this, highlight it, click insert, and then click on this. And click on this one. See, you give us the control chart. See, you can now add your title if you like. Let's put the legend. Oh, the legend is already there. So you see, can see how it is. So you can see how they move. This is the lower control. You can see the S bar center line, which is right here. So, this is center line right here. The one that's in purple, right here. And see the lower upper control limit in green and lower control limit in blue. You see that these 2 points here and here are out of control because they did not stay within the lower control limit of blue and upper control limit of green. They came out of the out of the range. So this process naturally is not in control. If it's in control, this line that is going up and down will be going up and down within the upper control limit and lower control limit. I mean, we didn't have any problem with the lower control limit because it didn't cross it. But they crossed the upper control limit like 3 times here, here, and here. Yeah, that's basically what control chart is. Now, the difference now is that in the question you'll be given, you yourself will calculate the mean and the upper and lower control limits using the formulas provided, and then you can be able to draw this chart. Okay. So let's do an example.
Professor,
Yes, ma'am.
how did you get the chart again?
Oh, the chart?
Mm-hmm.
Give me 1 minute. So these are the chart. The one I use here is the sample that I have here. Let me delete this one. And this is how this is a number that I made up. I made up these numbers, okay, to show you a picture of how it works. First thing is to highlight them. Okay, you listen?
Yes.
Okay, then copy them down. These are the given mean. These are the given upper control limit. This is the given lower control limit. This is the S bar. So you are plotting the S bar, given all this control limit. So you just highlight all of them. Then press the insert. Okay. Now go to this point, insert a line, choose the first one. That'll give you the control chart, S-bar chart. So you can call it the S-bar chart. Okay? Give you the title. The legends are already there. You can see that the green represents this upper control limit right here. See where the green one. And this the S-bar crosses it like 3 times. Here, here, and here. So it's out of control. The process is out of control. Okay?
I'm sorry, Professor. Do you mind doing that one more time, please?
You mean this one?
To get to that point, the steps leading up to that point.
I'm going to solve more on this. This is just the first one. This one didn't require much solving because I gave you out the S-bar, the means, and then this center line, upper control limit, and lower control limit. Then main thing that the S-bar stay the same because that is what you are plotting. Sorry, S-bar will be right here. This is the one that you are plotting, but the center line the center line, the upper control limit and the lower control limit stay the same. So that means you highlight them and then copy them down. Are you watching? This is the last attempt, okay? Hello? Hello?
Yes.
I'm watching. We watching.
Okay. Now, highlight it. Click on Insert.
Hey, Professor,
Yes, ma'am.
I have a question. Is this class recorded? Because I'm in South Africa and it's
It's recorded, yes.
6 8. Yeah, that's 6 8. Okay, thank you so much.
Welcome.
My connection's going bad too, Professor.
Huh?
My connection's going bad because I'm commuting right now.
Oh, no, I will not advise you to drive while listening to this. So if you're driving, I already...
No, not driving. No driving. I'm gonna pass.
Yeah. So, Prof.
Yes, I'm here.
So I have a question. So you're gonna teach us how to calculate the upper control
Yes, yes,
limit and the
yes,
and the lower control limit?
yes. We're gonna do
Okay.
it with the Excel. So it's gonna be part of the classwork that you do tonight. I'm gonna give you the classwork question, and then you can follow it and then watch. As you're watching this, you'll be doing it. When you finish,
Okay, thank you, sir.
you can come in, you upload it. So
Thank you.
the one I'm doing now is the one I'm going to do my demonstration for the class. Then after that I'll provide the class the question in the which you can access through the models. You can now calculate it, the upper control limit and lower control limit. Also, I want you to pay very put your ears to the ground here, because your project question will be based on this statistical quality control. Okay. Yeah. So now,
You said we have a project?
yes, of course, you have a project, and a final exam. You don't like projects? This
No, I don't like project. I don't like project. How's that going?
sorry to disappoint
Yeah.
you, huh?
Yeah, how is that? When did
project.
we set that up?
Huh?
When did we set up a project, sir?
I'm gonna set it up, then you work on it.
Oh, okay.
Yeah. So now,
Okay.
to finish this, then to draw the chart now, you highlight it and then click on insert. Okay, this is highlight it one more time. Click on insert, then click on this chart here. Choose the first one. I'll give you the control chart right here. Then you can now, when we do the other ones, I will show you how to label it. Otherwise, you can just label it, call it the S bar chart. X bar chart.
You didn't open it yet, right, Professor? I'm sorry. This is my last.
What?
Did you open the classwork yet? Or we wait until we get through?
No.
Okay.
Yeah. So S bar control chart. Yeah. So this just to give you an idea how it looks like. Now let us go back to the presentation and answer some questions there. Look at this question. It says, question 2 says, a construction company uses a machine to manufacture concrete slabs. Can you see the screen, guys?
Yes. Yes.
Okay. So
Yes, everything is
good. To ensure that the slab meets weight specifications, the quality control team collects weight measurements from the 5 randomly selected slabs each day for 10 days. The weights in pounds are recorded below. So this is where I recorded. I will show you where it is in Excel for this company. So I'm gonna make it be more bold. Okay, you can see it clearly. I have 2 companies here, so let me make it font size 14. So it says this is the product company for the construction company. See, this is the day, this is the weight in pounds for those concrete slabs. Okay. The question says, plot the S-bar control chart showing daily averages with the upper control limit, lower control limit, and the center line bar. Then, is the concrete slab production process under control, or is it out of control? So to do this, first of all, first thing to do is to make sure that you enter your data set clearly in Excel. So we'll be using the range for finding the upper control limit and lower control limit, because remember I told you that most time we don't know what the population standard deviation is. So what we do is to use the range and the table, this table here, this one here, to find the upper and lower control limits. So now, which means that the first thing we need to do, given that we know the data set is right here, as you can see, the first day, second day, third day, they have 5 samples each. Okay, I'm going to sample in. So the first thing is to find the range, and to find this range, we're going to use an Excel formula. This is the Excel formula we're going to be using to find the range right here. See right here, maximum. See, this is the formula we're going to use, find the range. Now, once you find the range, then next thing we need to find is the average weight.
So let me see that formula again.
Right here.
Okay.
So now let's find the range now. For this one, equals max, M-A-X. It pops out. Double click. Do it for the first data set. See? Close the parenthesis. Minus, repeat it again. But this I use minimum, M-I-N. It pops out. Double click. Then highlight again at the minimum part, okay? Close the parenthesis. Then, once you have it in this form, you press the Enter key. It will give you the range for that row. Okay? The range for that row. Now, I press the Enter key. Give it a 10. The good thing about
you drag it down.
Yeah, yes. I said just once you get the first one, just double click or drag it down. It will calculate the rest of them.
Wow.
I was trying to get you to do one more, but okay.
You want me to do it again?
No, it's okay. I'll watch the video.
Okay, good. Now,
Yes, please.
want me to do it again, sir?
Yes.
Okay. All right. Equal. Remember, the formula we're using, once you know the formula, actually it is, that's why I like to put it there. Equal sign first. Maximum, highlight the data, then minimum, highlight the data. Okay. So we have it right here. Equals maximum. Double click. Highlight the first that row that you want to calculate the range. Close the parenthesis. Then minus. This time type minimum, M-I-N. Double click. Highlight that same row. Okay. Close the parenthesis. Then press the Enter key after that.
Okay.
Then copy it down, copy the formula down. It will calculate the range for all of them.
So this is for maximum range or?
It doesn't matter. Maximum range. There's nothing like maximum range, Mr. Jupiter. Range is range is the difference between the highest value and this lowest value.
Lowest value, correct.
Yeah, and this is how Excel, does.
Oh, I thought I had you say that.
Okay, yeah, good. All right. Okay. Now
Can you
let's
do it one more time?
One more time. Remember, there's gonna be a video on this.
Or can you click on the formula? Sorry.
Yeah, of course.
Not one more time, but
right here. Do you know that it is also in the PowerPoint, ma'am? That one is even more bold. The PowerPoint. Okay.
And when you're gonna give us the assignment, you're gonna give us the data set, right?
Yes, of course.
Okay.
Now, it is the other one is the thing we need to calculate is the mean. Okay, and I will show you the formula for that. I know you did it already in the statistics class, but I'm still gonna show you. Mean is this formula here. A set formula that we use is the average.
Hold on.
See the average.
Average.
Then the weights, all the weights that you want to. Okay. It's the average. That'll give you the mean.
Okay,
yeah?
we got it.
So now we have the average for each row will be sample means.
Yeah, the sample mean.
Yeah, average.
Average.
It pops out. Double click. Highlight that first row. Close the parenthesis. Once you close the parentheses, you can press the enter key.
D32, H32.
Press the enter key, 502, and then you can just copy this down. Okay, that is sample me right there.
Mm-hmm.
Then, for the center line, which is the mean of all means, that's the next thing we need to calculate. The mean of all the means. So that's the next thing. Calculate the R bar and S bar. R bar is the mean of the range, and S bar is the mean of the means. Okay, and that will give us S bar and R bar. Okay, so you have S bar will be mean of the range.
Center line.
Yeah. So this is an R bar will mean of this. So let's get this one here. R bar, that means average again. Double click. Okay, I have highlight all this. Then close the parentheses. And then, I think I made a mistake. Yeah, sorry about that. I'm gonna do it again. Or average.
Average.
It pops out, double click. Then highlight all the ranges.
Mm-hmm.
And then close it.
Click enter.
Yep, press enter line.
Bingo.
Then you can
Sample me.
just copy this and it will calculate the other one here.
Oh wow.
So this is the range. R bar, R bar, R bar, and this is the X bar, X bar.
Mm.
Okay. I'm gonna just put highlight on this so you can see it.
Mm.
And this is their identification.
Mm-hmm.
Okay. Now,
I
the
like
center
that.
line. This number here becomes the center line. This X means something means. But I want to follow it step by step. That's why I'm doing it like this way. Now, next thing is to go to the control limit and then find the value under sample 5. Remember that the sample size we are using is how many of them for each row? 1, 2, 3, 4, 5 for each of them. So when you go to the table, okay, to find the A2, this is the table right here. I'm taking you back to where it's located right here. See the sample size N. This is the mean factor, A2. For 5, it is 0.577.
Mm-hmm.
So, and you can see it right here. I have it, A2.577. See that?
Okay.
Now, with this, we can now calculate the upper control limit and lower control limit. Okay? Now, using these two formulas, I'm going to write them out on paper since I've already shown them to you. If you look at it again, let me write them out. We have our arrow bar. You can see our arrow bar here as 23.2.
And the X bar 497.8.
Then S bar, they are also in Excel, 497.8. Okay. Then A2 is 0.577. Okay. Now, let us now go and put them in Excel or use them. So now you can see the formulas here. The formula is right here for the lower control limit and for the upper control limit. Let's take the upper control limit first. Okay, because you calculate that first. Then you calculate the lower control. Yeah, I mean, it doesn't really matter, but we get it. Oh, it's actually lower control limit comes here first. Okay. Okay, let me see. I put it first. So let me the first. Okay. Yeah. Now let's calculate the lower control limits first. Remember our mean here. This one is straight. We see the center line. So I'm gonna just put equal sign, click on it, or press enter, or I can just type it in. Now we can now calculate the lower control limit using this formula here. I'm gonna type our A2. A2. Let me type it right here. We got it at, if you remember, our A2 is 0.577. So I'm gonna go and put it right there. 0.577. I'm gonna make that section to be also be 14, so you can see it clearly. Here, it's at A2 right here. Okay. Now, using that, you can find the lower control limit. Equal, it says X bar, which is this one right here. X bar minus, in parentheses, this one here, times R bar. And our R bar is, you know what, let me organize this properly. R bar is right here. I can put this right here. R bar equals 23.1.
Correct.
Then X bar.
497.8.
I can just press equal sign and click on it again. Press enter key. It's right there. So I'm gonna all of them made them 14 and then highlight them. So you can use them now. Now you can now apply them now. Equal, okay, X bar minus, in parentheses, A2 times R bar. Close the parentheses. Make sure you close the parentheses after you do that. Okay? Then press the enter key. Now, that is for lower control limit. For the upper control limit, I'm gonna be using this one. So I'm gonna remove this. We're done with it. Okay. For the upper control limit, you got equal.
Professor. How did you get A2 again?
Do what again?
How did you get A2?
A2 is from the table.
Oh, from the draft and this
table in the presentation.
Table from the table.
Yeah.
Okay.
Want me to show you the table?
Yes, please.
You go to the presentation. It's right here. If you I have it in your Canvas, so you can download it right here. You can see since we have 5 samples, so A2 for 5 samples is 0.577.
Okay, I see.
So we got here we have equal X bar again, which is right here, plus this time parentheses A2 again times R bar. So make sure that you have your have this parentheses closed. Give us this. Now we're ready to draw the control charts. Now we have our sample means right here. Let me highlight this. Have a sample. See, sample means right here. I'm going to make it light green. Then you have the control limit, center line, lower control limit, upper control limit. So this one is the one that you copy them down all the way to the last one.
Correct. That's what I was asking. I wanted to ask that.
Copy them down. Yeah, all this hashtag is just because of this space. Just increase. Just double click on in any of them. Click on there, and then double click here, or just increase the space. It doesn't have the value. I see why. Yes. Give me 1 minute.
You did. Maybe you're supposed to lock them, all right?
No. Yeah. Yes. Let me double click on this. Log them up. Okay, by putting
the $sign.
Or you can just type them manually. Yeah. To make it easy for you, right? To make this easy for you, once you calculate them like this, you can type them manually, or you can just log them. Double click on it. Put the $sign before L and the $sign before this two column row 32, right? Then here, put the $sign before L, a $sign before 26. Then do the same thing here, $sign, and $sign here. Then do the same thing for each of them that you calculate the $sign before here. And the $sign for this one. And do the same here, double click, put the $sign before L. Okay. Then the same thing here for L here, $sign. $sign. Before this L again, $sign. Okay. Put in between 27, $sign. Enter key. Now you can just highlight them. Or alternatively, once you calculate them, you can type them manually. So that the formula will be gone. They copy them. When I click on this, I can see what you did here anyway. But I prefer that you put $sign so that can show that you did your work.
Can I see the formula one more time?
Which formula?
The UCL formula.
Right here?
Yeah. Oh wait, it's the LCL formula? Wait, hold on.
Yeah, lower control limit.
Okay.
Just LCL, yes.
Okay, hold on.
All right, so now copy this, then copy them down. With this, you're ready to draw the chart. Yeah, ready to draw the chart, right? You highlight from, so I'm gonna make these ones to be what color now? Make them a little bit pink. Yeah, that's better. Now you can now highlight it. Insert. Click on this one here. The first one. It will give you the chart.
Wow.
Okay.
Good job.
And this is for the for this construction company. What's the name of the company again?
Professor, how many questions is on this homework? On the classwork, I mean. Sorry, it's not even homework, it's classwork.
It's one question.
Okay.
Okay. Got you.
Yeah, this is the course right here. So,
yes, I'm loving it.
Yeah. If you want more question, I can put more if that's what you want.
No, I'll just repeat this one.
Devon, I need feedback.
This is for the construction company. That was the S-bar chart. S-bar control chart. Okay. For the company. So you can make it to be bigger, as it is. Like you can make it to be bigger by, you see? Control, I spell control wrong, correctly. Control, yeah. Now you can see the upper control limit. You can see right from the legend. These are for the different days. So let's add some title here. As this title. This one is for the day. Type in day. Because this, as you can see, that the day, each day, record that say day. Day 1 to 10, type day. Okay. This presents the sample means for that. Because this company, what does this company make again? This company makes concrete slabs. The machine they use to manufacture concrete slabs. Okay. To ensure that the slab meets with weight specification, the quality control team collects weight measurements from the 5 randomly selected slab each day for 10 days. So weight, sample mean, just the weights. So this is the sample mean, which presents the weight. Okay. You can even make it longer. So you can see that this is definitely out of control because this part, this is the weight. See, this is the lower control limit, this is the upper control limit, this is the center line. See, this one is went down below the lower control limit. So the process is not in control. That is why I wrote here in the presentation that as you can see, it's from here. See what I wrote here about it. So the SBAR control chart, you can see that the sample mean for day 5, because that is for day 5. You can see that was out of control. See, this is on day 5. You can see 5 right there, day 5. So the sample mean for day 5 is not outside the lower control limit, but below. So it's clear below the lower control limit. That means that the process mean is not in statistical control. Okay. Any question, guys?
Yes, one question, sir. So, in the same, in this one, it went below the lower control limit. And the other one, when it went above the upper control limit, what do we call it? Do we also say that it's outside?
Yes. Once you go above the control limit or below it, it's out of control.
So I have a question.
Yeah.
So why didn't we calculate the average of the other ones? The lower and upper control limit. Why didn't we calculate the average? Yeah, like here, like the way we did on the simple mean and
we already calculated
the range.
We have the average of each of these rows already. Then we calculated the average of we also calculated the average of the sample mean and the average of the ranges. Remember? So all the averages we calculated them already.
Okay.
Mm-hmm. So these are the control limits. So to go back to the other student's question, once it is go above the upper control limit or below it, it's out of control. Now, this is for day 5, right? If I remove that day 5, if I clean it up by removing day 5 completely, I remove this row for day 5. This for the 5. Watch this. And then, you know what? Let me undo this. So this is for day 5, right? If I remove this, the sample mean for that, let me see. Yep. If I remove the sample mean for day 5, 1, 2, 3, 4, 5, which this is covering it. Oh, I think it's up here. So I'm going to place it side by side. Watch me remove the sample mean for day 5. This one right here. This is one right here. I want you to watch the graph as I do that. See?
Oh, I see.
Yeah,
It changes.
yeah. So everything will fall into control now.
Mm.
If I undo it, it's back to where it was. So you can identify the cause of the variation and then fix it, and then the machine will start working. Now I think that's
So the day 5 comes from the question, right?
yes.
Okay.
So now having said this, I think I'm gonna give you the rest of the time will be I think you spend it working on the classwork. So I'm gonna prepare the classwork and put it there. Check back the next 30 minutes. Your classwork question will be there. Okay.
Okay.
I had a question.
Yes, ma'am.
Thank you. Did you get me for attendance? Because I have to go.
Yeah.
That's all.
Devon.
Class is over anyway.
Devon.
I have to go. Is that all?
Let's do this one after the other. What the lady wanted.
I thought the class is done though.
Mr. Tevon, email me, man.
Hold on. The lady was asking a question.
It's Jupiter.
Go ahead, Miss Smith.
Okay, thank you. So for the assignment that you said we could make up, you said you would assign a new one. When would that be sent? Because I'd sent you an email before for that assignment and I actually completed it, classwork 7.
No, that one is already great. That one, if you're making up the email, you list the name of the assignment that you want to make up. So what I'll do is to check the attendance score. Then I'll email you.
Yes.
So if your attendance score is good, you have to be patient. I'm gonna get to you.
Okay, because I've emailed you before and what? I'm still talking.
Sorry about that.
I've emailed you before and you haven't gotten back to me. So if I send it right now,
what's your name?
I'm sure that I'm able. Caris, Caris.
I mean, what's the last name? I mean,
Jackson.
Have a good one, Professor.
You too. Just okay. I started your class, this week. Remember last week I said I'm supposed to start last week, but I started this week because I have to go through. I have a lot of emails and classes I'm teaching, so I have to go one by one. So I'm gonna get to you.
Okay, so is there any chance
in any case, send it again tonight. Okay.
Okay, and
don't forget to put the names of the assignment, not more than 5.
Do you know the deadline for that? Because it's just classwork.
I'll give you the deadline.
Okay. Thank you so much.
Welcome.
So Prof.
Yes, sir.
Prof, the same question that Caris asked, I emailed you. Mine is just
I'm seeing your email. I haven't gotten to you yet.
Okay. Thank you, sir. So okay, we'll be waiting. He said in the next 30 minutes. But what we did is awesome. But I don't know if what the one you're gonna send is gonna be complicated. We don't know.
It's something similar. Just watch.
Lord Jesus.
Watch the video and follow the direction from the video.
Okay.
All right.
Yes. So the one at the bottom is what they say question 3. That's different.
The different question.
Okay.
Yeah, it's a different question.
Okay.
So are we only gonna have to do question 3?
I'm gonna give you not question 3. I'm gonna give you the one you do.
Okay. Professor, I have a question too. Not really a question, but can you please get back to my email? I emailed you like 2-3 times.
About the makeup?
Yeah.
I'm gonna get to you. You didn't hear what I said to the other 2 people?
I was just making sure that you knew I needed to that I said something to you. I just wanted to be known,
Oh, yeah, but is your attendance up to 70%?
I believe so. Yeah.
No, you have to be. You don't have to believe. It has to be 70% for you to get a response. If it's 70% or more, and you haven't gotten a response from me, just be patient. I'm gonna get to you.
All right.
Hey, Professor, help us.
But my attendance is 70%. I'm 100% confident.
Amen.
All right, guys, I'm gonna leave you so I can set up the classroom.
You said this class is the last class for. You remember last time you said this was going to be the last class? Is it the last class?
No, we still have another class next week, but it's
Okay,
going to be.
thank you, Jesus.
But it's
Okay,
going to be,
thank you, Jesus.
gonna be remote
Thank you,
class.
Jesus.
Sure.
Okay, all right.
All right. Have a nice day. And let me set up this.
Thank you, sir. Remain blessed. Remain blessed.
Is
I have a
Caris
question too.
Jackson?
You give me for
Caris
attendance.
You have
Jackson?
a nice day, Professor.
What was that?
Yes, hello.
You say you have a question, right?
Yeah, I'm sending you the email right now about classwork 7.
Okay. Now,
Thank you.
Chase, you're welcome. Chase, right? Was asking a question, right?
No, that was Justin. I was asking if you got me for attendance.
For attendance, Justin Smith, right?
Yes.
Most of the, I've got almost all of you. They have you, yeah.
Okay, thank you.
Did you get Blanche Gold?
There's someone
Blanche Gold?
here. There's someone here who was what's his name? He just showed a different. I have not seen that name before. Yeah. Anyway, if you don't have any question, let me log out so I can set up your classroom.
Professor.
Yes,
Can you
yes,
hear me?
man. Yes, sir.
Did you get Blanche Gold for
Huh?
attendance? Blanche Gold.
Yes, I have Blanche Gold.
Oh.
Yes,
Do you
I have
have Professor? Did you get me for attendance? Mbasabutlo.
Mbasa. Yes, sure. I got you.
Have a good one, Professor.
Did you get Tiffany?
Tiffany, what are you doing here? You're supposed to be graduating, right?
Oh, I'm doing it. I didn't know if I was supposed to come or not. I still.
Have you done the homework yet?
Yeah. I was gonna turn that in today, actually.
Yeah. Then I also emailed you the.
Yes, I got it. I was working on those too.
Okay, very good. So I got.
So I don't have to worry about. The this classwork, right?
Of course, you have to worry about this class. Only this one. After this one, no more for you.
Okay, so do this classwork.
And you're
The
done.
homework and then the exam and project. Okay.
Yeah.
Okay, thank
Professor?
you.
You're welcome.
When is everything due again?
Huh?
When is everything due again?
What do you mean everything due?
The homework schedule. The
You mean
ones that you
classwork
open.
tonight?
No. Tonight.
The classwork is due tonight, but you can I can submit it tomorrow. I'm gonna extend it to tomorrow.
Okay, thank you. And then another question that I have is, sorry, where can I find the video that we recorded today for the class?
In the class when I put the classwork, I'm gonna put the link under the after the question. You see the question under the question. You see the link.
Okay, thank you.
Welcome.
All right, that's good. Thank you. Have a good day.
You too.
Okay.
All right, guys.
Professor, I have a question about the AR still.
David Bachman, right? I'm checking.
Yeah.
What's the question, sir?
Well, looking on the graph in the slides in the PowerPoint, it says like you said, it's 0.577 when the sample size is 5. But the sample size for this graph was 10, so why was it still 0.577?
You said the sample size is what again?
The sample size for the graph that we were using was 10.
No, it's not. Let me show you. It's the number of days that is 10. This is a sample right here. Can you see the screen?
Oh, okay, I see.
1,
Yeah.
2, 3, 4, 5. These are just
Okay,
the number of days that the samples we are selected.
All right.
Okay. All right, guys. Again, I'm gonna let you go so that I can set up this assignment. Okay. All right.